This is the second screencast, which discusses section 12.4 of the two-box model chapter. So let me remind you where we're at. We obtained data from the IPUM's CPS March 2013 data set, and so that's this one, March 2013, on various variables. We're interested in the difference between the hours worked by people with a high school education versus hours worked by people with a college education, and we're going to throw sex into the mixture as well. So we last found ourselves sitting here. We'd created a log file in order to track what's going on. We called it analyze hours by sex and education.log, and we already opened the data set. It's called CPS 00067. We've got these variables here. Now, to facilitate the analysis, I'm going to use a do file, and the do file here, let's go find the do file. I'm going to open it up, and in downloads there's the do file, and you of course can obtain this from the appropriate place on our website, the Canvas site. Do file's got a bunch of stuff here, and what I'm going to do is I'm actually going to go run this do file, and one way to do that would be to do tools and run. Another way to do that would be to go back to the mains data setup, go to do, and let's see, I actually need to go to downloads because that's where the most recent version of this is. There we go. So it's going to do a bunch of stuff all at once. That's what a do file does, and in fact, not quite done. Here, let's go back and take a look at the beginning. So these lines which begin with a star are comments. First, we want to find out what the education codes stand for, and so we did tab educ. We're interested in high school diploma or equivalent versus bachelor's degree. Okay, so we can see there are about 37,500 observations in high school, almost 26,000 observations for the bachelor's degree. Now, I don't know what numbers these are, but if I take a look at it, code 111 is people with a bachelor's degree, code 73 is people with a high school degree. Okay, I'm going to create some dummy variables. So gen hs equals education equals 73. So that generates a dummy variable, which is 1 if education is 73 and 0 if it's not. So that codes for high school. Same deal with college. The 111 code is college. All right. Next, I will create a variable for total hours worked. That's simply weeks worked times hours worked. Weeks worked in 2012 multiplied by usual hours worked per week in 2012. And I can do a summary, and college, about 20% of our sample is a college degree, stopped with a college degree. 29% stopped with a high school degree. Hours vary from 0 to 5,148, and that's not a surprise because hours worked per week varied from 0 to 99, etc. Okay, so keep if hours greater than 0 says let's drop all the observations, all the individuals who did not work, didn't have any hours last year. All right, so only if hours are greater than 0. Then keep only those people with a high school or college education. Drop if high school equals 0 and college equals 0. So if either one's equal to 1, we keep people. And we now have a lot fewer observations. All these people worked, and 56.6% of them are high school graduates, 46.4% are college graduates. That adds up to 100. Hours now averages 1,942. Now I need to figure out who the males are. Well, males are number 1. Generate male equals sex equals 1. That's a dummy variable, which is 1 if sex is 1, and it's 0 if sex is 2, which is females. Okay, so males are about 53% of the population. Yeah, that's right. It's 23 versus 20. Okay. Now, here comes the work. We're going to do a t-test. We're going to test for the equality of mean hours between people with college and with high school education levels. And I need to turn back to our text to talk about what's going on. Okay, so here's the textbook. Here are the null and alternative hypotheses. The null hypothesis is that the average number of hours worked for workers with a college degree is equal to the average number of hours worked for people with a high school degree. The alternative hypothesis is a little different from what's stated here. We'd actually do a two-tailed test. The average number of hours worked by workers with a college degree is different from, not equal to, the average number of hours worked for workers with only a high school degree. And what we're going to do, these are claims about the population. Okay, so we're talking about workers with a college degree versus workers with only a high school degree. But we have sample data. So let's turn back to Stata. Okay, so here's the test. We're going to test for the equality of average hours between people with college and high school education levels. So we're going to use this statement: t-test hours. We're going to separate it by the level of this COLL, college variable. 0 is people with a high school education. Our sample is 23,286 people drawn from the high school box. 1 is people with a college education. We've drawn 2,155 people from the college box. We can compute sample averages, 1,889 hours and 2,003 hours respectively. We can talk about the difference between the two. If we subtract 2003, the college sample average, from the high school sample average, we get a difference of minus 114. We can compute the standard error. Now, the reason why this thing is called unequal is we're assuming unequal variances. That's what our formula is about. It's the square root of the first standard error squared plus the second standard error squared. Take the sum of those squares, take the square root of it, and you get this number here. That's the standard error for the difference of the sample averages. Now we can construct a test statistic, which is what we observed in the sample, a difference of 114 hours, minus 114, minus what we expected in the null hypothesis, which is 0, so that preserves minus 114. Divide that by the standard error for the difference of sample averages, and we get a number which is minus 17. We call this a t-statistic. With very large samples like this, we could have just made this a z-statistic, which would appeal directly to the normal distribution. The t-distribution looks an awful lot like the normal distribution when we have really large samples like this. So what does that huge t-statistic mean, that huge test statistic? It means that that we're very, very far away from what's claimed in the null hypothesis. Our p-value is infinitesimally small. The chances of getting a result like this, if the null hypothesis is true, if population average hours for high school people and population averages for college people is equal to the difference is 0, we would never find this t-statistic. We conclude that there really is a difference between hours worked by college-educated people, hours worked by high school-educated people. So that's our first test. I'm going to talk about the others in the next screencast. See you soon.